Good morning, students. Myself is Dr. Santosh Choudhury, a reader in chemistry. Last class I discussed about the physical and chemical properties of alcohol and the reactivity of the alcohol due to the presence of polar bonds. The polar bond is present between the carbon and oxygen and hydrogen, because the oxygen is more electronegative than the carbon as well as hydrogen. So during the reaction of alcohol, either carbon oxygen bond is break or oxygen hydrogen is break. So certain reagent which is capable to break the oxygen hydrogen bond and certain reagent which is capable to break carbon oxygen bond. So the reaction of the alcohol due to the cleavage of oxygen hydrogen bond and the cleavage of the bond between carbon and oxygen bond. Okay, students, and first we discuss the cleavage of reaction of alcohol due to cleavage of oxygen hydrogen bond. That is the reaction of alcohol due to cleavage of oxygen hydrogen bond. So during the reaction, the oxygen hydrogen bond get cleaved, and the reactivity order during cleavage of oxygen hydrogen bond is primary alcohol is more reactive than secondary alcohol is more reactive than tertiary alcohol. So during the reaction of alcohol cleavage of oxygen hydrogen bond, the reagents are metallic sodium hydride, carboxylic acid chloride, Grignard's reagent. Means when the alcohol react with these reagents, the oxygen hydrogen bond is break, or the hydrogen atom of OH group of alcohol is substituted by a nucleophile. Substituted by a stronger electrophile. Okay, students, first we will discuss the reaction of alcohol with metallic sodium. A reaction with metallic sodium. So the alcohol, particularly the primary alcohol, when react with metallic sodium, this hydrogen atom replaced by sodium to form corresponding sodium alkoxide plus hydrogen gas, and this is called alcohol. This is called sodium alkoxide. Sodium alkoxide, because when this is OH, means H, R become H sodium hydroxide. If the H is your alkyl group, we can say this alkoxide. That means methoxide, ethoxide, propoxide, like this one. Okay, suppose I will take methyl alcohol react with metallic sodium, gives what? The hydrogen atom of methyl alcohol is replaced by sodium. It gives you CH3O Na plus half hydrogen. Okay, if you take ethyl alcohol plus sodium, so it gives CH3 CH2O Na plus half hydrogen. This is called sodium ethoxide. If you take tertiary alcohol, suppose I will take a tertiary alcohol, suppose this is your tertiary butyl alcohol that reacts with sodium, it gives what? You know, during the reaction of alcohol with sodium, the oxygen hydrogen bond is break, but and the reactive order is primary is more reactive than secondary, is more reactive than tertiary. In this case, we will not get a alkoxide. Rather, we will get a alkene, that is isobutene, because sodium acts as a strong base. And the tertiary alcohol when treated as a strong base, it undergoes elimination reaction, it goes isobutene. Okay, this is the reaction of alcohols with metallic sodium. The reaction concludes that alcohol is acidic in nature. For example, if you say HCl acid, because the hydrogen atom possesses fractional positive charge or positive charge. Similarly, in alcohol, the hydrogen atom is bonded to OH group, that is acidic in nature. That's why alcohol is acidic nature, it is less acidic than water. So the acidic odor of water is more acidic than methanol, is more acidic than ethanol, which is more acidic than isopropyl alcohol or secondary propyl alcohol. And the tertiary alcohol never shows any acidic character. That's why alcohols are acidic nature, but it is less acidic than water. That's why when the alcohol dissolved in water does not produce any H plus ion like HCl, because alcohols are less acidic than water. Okay, students, and the acidic strength of different alcohol, water is more acidic than methyl alcohol, is more acidic than ethyl alcohol, because they increase the bulky alkyl group than isopropyl alcohol. Again, the mixture of ethanol plus sodium, this will act as a reducing agent. This act as a what agent? Reducing agent. What is reducing agent? Any reducing agent have tendency to produce nascent hydrogen. So this nascent hydrogen reduces the substrate molecules. Okay. So when this will react to produce, that is C2H5ONa, sodium ethoxide plus the nascent hydrogen. That's why the mixture of sodium and ethanol act as a reducing agent. Okay, student, this is the reaction of alcohol with metallic sodium. Similarly, alcohol can react with metal like lithium, as well as zinc. So, second reaction with sodium hydride. So, alcohol react with sodium hydride, it gives you sodium alkoxide plus hydrogen gas. Suppose if you take methanol, that react with sodium hydride, it gives sodium methoxide plus hydrogen. Similarly, ethyl alcohol. Next come to reaction of alcohol with Grignard's reagent. What is the name? Grignard reagent. The Grignard reagent is your RMgX. So any alcohol, for example, primary alcohol, that is R-OH, this is your alcohol react with your Grignard reagent RMgX. It gives what? It gives the alkane. It gives the what? Alkane. What alkane? The alkyl group of the Grignard reagent. The alkyl group of the Grignard reagent that react this hydrogen to give alkane. RH plus MgOR-X. This is your alkane. You see how the alcohol can be converted into alkane, not the corresponding but the alkyl group of Grignard's reagent. For example, if you take methyl alcohol react with ethyl magnesium bromide, it gives what? Suppose methanol react with phenyl magnesium bromide, and this is phenyl magnesium bromide. What product it gives? Generally, these reactions are taking place in what? Dry ether medium, because the Grignard is very reactive towards water. So it gives what? This C2H5, this H, it became C2H6. This gives you C2H6. This is your ethane plus what product? MgOCH3. What product gives in second reaction? In second reaction gives you benzene. C6H5, this is, that is, it gives you C6H6, this is your benzene. Plus MgOCH3Br. Okay, this is the reaction of alcohol with Grignard reagent. And when the alcohol reacts with Grignard reagent, the bond, oxygen hydrogen bond, get cleavage. Now come to reaction with carboxylic acid. What is carboxylic acid? That is RCOOH. Means RCOH is called carboxylic acid. So the alcohol that is RCOOH, this is your carboxylic acid, and R-OH, this is your alcohol. When the alcohol react with your carboxylic acid, that will give a ester. How this ester? The OH group of the carboxylic acid, the H of the alcohol. Mind it, not this OH. The OH group of the carboxylic acid and hydrogen from the alcohol are combined to form a molecule of water and result to form RCO. RCO. This one is bond OR dash plus H2. And this is called ester. And the formation of ester from the alcohol and carboxylic acid is called esterification. But formation of ester from alcohol and carboxylic acid is called esterification, and esterification is a reversible process. If it is reversible in nature, the reaction is not completed. To make the complete the reaction, you apply the Lee-Chapters principle, means we have to remove some water to make it irreversible. To remove this water, you are using here some concentrated sulfuric acid. Because the concentrated sulfuric acid is a dehydrating agent, means which can absorb the water molecules and the reaction became forward. So the concentrated sulfuric acid acts as a dehydrating agent during the esterification. If the concentrated sulfuric acid can replace, that is by dry HCl gas, the same reaction can also be carried out. And if the dry HCl used during esterification, that is called a specific reaction is there, that's called Fischer-Tropsch reaction. Fischer-Tropsch reaction. That is, what is Fischer-Tropsch reaction? It is one type of esterification. The dehydrating agent is dry HCl. Dehydrating agent is what? Dry HCl. Okay, now come to some specific examples. Suppose you take acetic acid, that is your ethanoic acid. Suppose it react with ethanol in presence of concentrated sulfuric acid. So, what will happen? The OH group of carboxylic acid and H of the alcohol are produce a molecule of water as a result to form CH3, CO, OC2, H5 plus H2O. This is called ethanoate. Ethyl acetate. This is the ester. So, what is the rate of esterification of different alcohol? Rate of esterification of alcohol means which alcohol will produce ester readily. You see, during the esterification, there is a cleavage of oxygen hydrogen bond. The reactivity order is, that is your primary alcohol can readily form ester with carboxylic acid, then the secondary alcohol and the tertiary alcohol probably does not form ester. Because in tertiary alcohol the oxygen hydrogen bond is very strong least reactive, and there is a presence of a bulky alkyl group. Bulky alkyl group. That's why the tertiary alcohol does not form any ester. Okay, student, this is your esterification, and next come to reaction with acid chloride or acid anhydride. What is acid chloride? Means RCOCl or RCO whole twice O. This is called acid anhydride. And the action of acid chloride or acid anhydride with alcohol is known as acylation. Because the hydrogen atom of the alcohol, that is the hydrogen atom of OH group of the alcohol, is replaced by acyl group. That's why it's called acylation. How it is? This is your alcohol, OH group present in your alcohol, and this alcohol suppose react with the acid chloride acetyl chloride, CH3COCl, it get lost molecular HCl, and this hydrogen atom of alcohol, this part is from alcohol and this part from acid chloride to form the corresponding ester. And this one is called acylation because the acyl group is substituted for the hydrogen atom of alcohol. So definitely there must be an acylation, the molecular mass of the product increases as compared to alcohol. How much increases? There is a one hydrogen lost from the alcohol. Okay, one atomic mass of hydrogen, 1. But what mass of this one? This mass is 43. And this mass is 1. When H is converted to ester or acylation, then increase the mass, increase in molecular mass of the product or of the alcohol by acylation is by 42. So if there is a 2 OH group which are acylation, how much molecular mass will increase? Yes, 42 into 2. If there is 3, there is 42 into 3. Because the 3 OH group of the molecule, the hydrogen atom get replaced by the acyl group. That's why the acylation gives the estimation of OH group in your compound. Acylation gives the estimation of OH group. This means per molecule how many numbers of OH group that can be estimated by the acylation. Means you take the alcohol, you treat it with acid chloride, that is CH3COCl or acid anhydride to form the corresponding acetyl derivative and measure its molecular mass, and what molecular mass of alcohol, the difference that gives the number of acyl group present in your product, and different molecular mass is divided by 42, that gives you number of OH group. Okay students, let us see. That means the number of OH group present in the sample is equal to increase the molecular mass on acetylation, means reaction with CH3 COCl divided by 42. That is, increase the molecular mass of sample on acylation. What mass is increased? That divided by 42, that gives the number of OH group present in your sample. Okay students, let us see how the acid chloride alcohol react with your acid chloride. Suppose this is your alcohol, this is your CH3COCl, this is your acetyl chloride. On acylation, the heads of the alcohol Cl from the acid chloride or acetyl chloride, it gives you a ester CH3CO. This is an ester plus what? HCl. Suppose if you take methanol that react with acetyl chloride, it gives you the H from the alcohol, HCl from acid chloride. This gives you CH3 COOCH3 plus HCl. This is called methyl ethanoate. Okay student, this is called acylation, and by acylation we can estimate the number of OH group per molecule. Next, these are the reactions of alcohol due to the cleavage of what bond? Oxygen hydrogen. Now we come to another one. The reaction of alcohol which is due to the cleavage of reaction of alcohol due to cleavage of what bond? Carbon oxygen. So during the cleavage of carbon oxygen bond, the reactivity order is tertiary alcohol is more reactive than secondary alcohol, which is more reactive than primary alcohol. And the reagent which are used to break the carbon oxygen bond in your alcohol, the reagents are Lucas reagent, that is your phosphorus halide, that is PX3 or PX5 or what is that one? SOCl2, this is your thionyl chloride. And this reaction already the preparation of alkyl halides from alcohol. And what type of reaction I have discussed there? This is one type of nucleophilic substitution intramolecular SNI reaction. What reaction? The reaction is called SNI, nucleophilic substitution intramolecular. That means within a molecule they create a nucleophile. So I summarize little bit. The alcohols react with Lucas reagent. What is that? This is important for us for the alcohol chapter. What is this? Lucas reagent. Lucas reagent is a mixture of concentrated HCl in presence of anhydrous zinc chloride. Because why you take anhydrous? So the H of the HCl and OH of the alcohol, they combine to form water, and this water can remove in presence of anhydrous zinc chloride. That's why we are using anhydrous zinc chloride as a catalyst. And the reactive order is what order? That is tertiary, more reactive than secondary, is more reactive than primary. The tertiary alcohol is very reactive towards this glucose reagent, that way it does not require any anhydrous zinc chloride, because it is very reactive. That means the tertiary alcohol immediately react with the HCl to form the corresponding alkyl chloride, and this alkyl chloride is a white precipitate in water. That means the glucose reagent immediately react with tertiary alcohol to give the white precipitate of tertiary alkyl halide or alkyl chloride. Okay, students? And what about secondary? The secondary alcohol less reactive than this one. So the glucose reagent react with the secondary alcohol to give the white precipitate alkyl chloride after 5 minutes. And what about the primary alcohol? Primary still less reactive. So to give the precipitate, it requires some heat. So from the sample, a sample is given to you. You know, alcohol colors liquid. A sample of alcohol is given to you. We have to identify whether the given alcohol is primary or secondary or tertiary. Mind it, there is no structure. The sample doesn't give any structure. The sample means just like a water, or sample is given to you, test whether it is a primary or secondary or tertiary. Then we have to test this. That is called Lucas test. You put some Lucas reagent. If it gives the white precipitate immediately, the sample is tertiary. If the sample gives the white precipitate after 5 minutes by standing, then the sample is your secondary alcohol. After 5 minutes, the sample does not give any precipitate, the glucose reagent. You simply warm this. If you warm this, if they give the white precipitate alkyl halide, then you can sample is a primary alcohol. Okay, students? So we can identify, you can distinguish the primary, secondary, tertiary alcohol by Lucas reagent. That's why it is called Lucas test. Suppose the sample does not give any precipitate even after the heating, then what is it? It is not alcohol. It is not alcohol. It is neither primary nor secondary nor tertiary. If it is an alcohol sample, then it react with the glucose reagent, then give the precipitate of alkyl chloride after in different interval or upon by heating. Okay, students, let us see how the alcohols are react with Lucas reagent. That is yours. I have already discussed this thing. I will take a substance. Suppose you take ethyl alcohol, you treat it with Lucas reagent HCl in presence of anhydrous zinc chloride. It gives you a white precipitate CH2, CH3, CH2, Cl plus H2O. If you take HBr, it gives CH3, CH2, Br plus H2O. If you say treated with HI, because reacted out of halogen acid, HI is more reactive than HBr than HCl. It reacts immediately, it gives CH3, CH2I, H2. You see how the alcohols are get converted into corresponding alkyl halide by the action of HCl, by the action of HBr, by the action of HI. You remember the OH group will get converted into Cl or Br or R. This is called chloroethane, bromoethane, iodoethane. Okay. You will discuss the Lucas reagent in detail when I identify or separate also test for primary, secondary, tertiary alcohol. Next come to alcohol react with, suppose you are PCl3 or PCl5 or thionyl chloride. And this thing already I have discussed, that is the OH group of the alcohol get converted into the Cl. So this gives you RCl plus H3PO3, and this gives you RCl plus SO2 plus, and this gives you RCl POCl3 plus HCl, and this gives you what reagent is called? What reagent? Associated with known as Darjan's reagent or Darjan's reaction, and it gives you RCl plus SO2 gas plus HCl gas. And these things already discussed thoroughly in your alkyl halide preparation of alkyl chlorides. That's why you are not discussing very thoroughly, and you go my Hello Alkane chapters video clipping. And this is all about the reaction of alcohol with due to cleavage of carbon and oxygen bond, and during cleavage of carbon oxygen bond it undergoes the reactive order is tertiary is more reactive than secondary, is more reactive than primary. Okay, next come to the reaction of alcohol, that is called your elimination reaction. That is dehydration of alcohol. What is a dehydration? Dehydration means, loss of H2O, it's called dehydration. Loss of H2O, it's called dehydration. Or addition of water, it's called hydration. Addition of means addition of water. Loss of water by the reacting molecule, that's called what? Dehydration. Okay, so what do you mean by this elimination reaction? I will already discuss the elimination reaction means one type of beta elimination. The two atom or group eliminate from the consecutive carbon atom. As the alcohol possesses the OH group, it gets lost molecule of water, then this bond and this bond come to a double bond. Means it gets lost molecule of water. How? We are using some dehydrating agent. Dehydrating agent means which can remove the molecule of water. And what are the dehydrating agents? The dehydrating agents are concentrated sulfuric acid at a high little bit temperature. We maintain some temperature. Or the dehydrating agent is your anhydrous aluminum oxide. You know, aluminum oxide is a dehydrating agent which can absorb the water molecules. It became aluminum hydroxide or anhydrous chromium oxide. So see, the alcohol when treated with dehydrating agent, it undergoes the dehydration, means a loss of molecule of water, and result to form what? Result to form an alkene. That is, alcohols are dehydrated to form the alkyl. And what will be the reactivity orders? And the reactivity order, you see, there is a cleavage of carbon-oxygen bond. The rate of reactivity order to our elimination reaction that dehydrated, that is rate of dehydration is the tertiary alcohol is more dehydrate or more readily dehydrate than the secondary alcohol than the primary alcohol. Okay students, let's come to how the different alcohols are dehydrated to form the alkenes. During the dehydration, it also follow the what rule? Sizef's rule, that is the elimination of proton from the alpha carbon atom taking place which side or which carbon have more branching. So suppose I will take R CH2 CH2OH. This is your primary alcohol. When you treated with concentrated sulfuric acid at about 190 degrees C, it undergoes elimination. The OH group of this carbon and heads up the alpha carbon, nearby carbon, and this will come to here double bond. What product will get? That is R CH2, means one H is get removed, that becomes CH double bond CH2 plus H2. Suppose I will take ethanol, that is treated with concentrated sulfuric acid 190 degrees C. What will happen? This H, this OH. This H and this OH form the corresponding alkene, that means ethene. This is your ethanol. And this dehydrating agent, what you taking from the sulfuric acid, we can replace by using anhydrous aluminum oxide or anhydrous chromium oxide. Suppose you take a secondary alcohol, what product will gives? Suppose you take butane 2 oil. When you treat it with dehydrating agent like your concentrated sulfuric acid, and the temperature now come to 140 degrees C, because it's secondary. For primary it required 170 or 190 degree, but here it was 170 degree. It gives the two type of product, and as the one elimination taking place, this alpha site and another elimination may taking place this side. So you will get two type product. One is called whatever. If you can elimination these two types, that is became CH3 CH double bond CH CH3. This is called but 2 ENE, and this gives you CH2 double bond CH CH2 CH3. This gives you but 1 ENE. So this is according to a Saijev's rule. Okay students, this is all about our elimination reaction and what the mechanism of this reaction. Mechanism of elimination reaction, or you can say mechanism of dehydration reaction. Do you know what is mechanism? Mechanism means the pathway of the reaction. How the reaction is get converted into the product, and what intermediate steps are there, means which bond is break fast, which reagent will attack first. That's called mechanism. Let us see mechanism of dehydration reaction of alcohol. Suppose you take ethyl alcohol, or suppose you take propanol, CH3 CH OH CH3, and this is your propane 2OH. This is called what? Propanol. Suppose you are taking sulfuric acid. That is, sulfuric acid provide you H plus ion. That is a proton. What will happen? This proton first affect this one. That means this proton get attracted towards the lone pair of electron of oxygen atom of the OH group. So this became, that is, you can say CH3 CH OH2, a lone pair electron and a positive charge, because a electron is used, and this is called CH3. This is called protonation of alcohol, or, and this is unstable. This immediately get lost. Immediately this lone pair electron of oxygen lost a molecule of water. When the protonated alcohol lost molecule of water, it form a carbonium ion. That is, carbonium ion means the carbon atom carrying what charge? Positive charge. This is your carbonium ion intermediate. Carbonium ion what? Intermediate. What will happen? This carbonium ion now rearrange. That means it got lost a proton. Means it lost a proton, and this electron pair come to here. It became CH3 CH CH3 CH. What will happen now? This, in this case, double bond CH2, and this is your propene. You see, this proton is used, and here sulfuric acid is used. So we can say how the proton is lost here. The proton is lost in presence of the conjugate base of the sulfuric acid. This is a conjugate base of the sulfuric acid, and now this one can try to eliminate a try to eliminate a proton. It became what? It became H2SO4. And this is the mechanism of the dehydration of alcohol to form the corresponding alkene. So the dehydration of alcohol generally taking place in presence of acid catalyst, and the rate of dehydration of alcohol is what? Tertiary is more than the secondary, is more than the primary. Okay, students? So these are the mechanism of the reaction or mechanism of dehydration of alcohols. Okay, students? Now, how do the alcohols react with their sulfuric acid? That is reaction of alcohols with sulfuric acid, that is alcohol. Suppose you take methanol, it reacts with sulfuric acid, comes a sulfuric acid, it gives a different product under different condition. Suppose it reacts with sulfuric acid at 120 degrees C, suppose. This hydrogen atom is protonated and it gives a protonated alcohol, or you can say it gives CH3, CH2, O, SO3H. That is called ethyl sulfonic acid. Because the OH group of alcohol, and OH group of this one, this is the ethyl sulfonic acid. This is your this one, SHO4, and that is the sulfonic acid, ethyl hydrogen sulfate. Sorry students, this is called ethyl hydrogen sulfate. When you take concentrated sulfuric acid at 190 degrees C, suppose you take excess, it forms CH3, CH2O, CH2, CH3, this is called diethyl ether. Suppose you take concentrated sulfuric acid 170 degrees C, but excess of alcohol. In this case, it will form ethene. It will form what? Ethene. Okay. Here you take the excess of alcohol. In this case, you take excess of sulfuric acid. So, the ethanol gives different product by the action of concentrated sulfuric acid in a different condition. Okay, students, these are the reactions of alcohol, and in this today we have already discussed the reaction of alcohol due to cleavage of oxygen hydrogen bond, and the reactivity order of alcohol due to cleavage of oxygen hydrogen bond is your primary alcohol is more reactive than secondary alcohol is more reactive than tertiary alcohols. and the oxygen hydrogen bond of alcohol get cleavage when the alcohol react with sodium hydride, Grignard reagent, alkyl lithium, or carboxylic acid chloride, acid anhydride. And we have discussed the reaction of alcohol due to cleavage of carbon oxygen bond. During cleavage of carbon oxygen bond, the reactivity order is tertiary alcohol is more reactive than secondary alcohol is more reactive than primary alcohol. And the carbon oxygen bond get cleavage due to the attack of the nucleophile to the positive charge carbon atom, that is due to your reaction with Lucas reagent and halides, trihalides of phosphorus, pentahalides of phosphorus, and thionyl chloride. And we have discussed the elimination reaction of alcohol. The alcohol undergoes dehydration in presence of the dehydrating agents, and alcohol and dehydrate gives you corresponding alkene by losing a molecule of water. Next, you have discussed the action of alcohols with concentrated sulfuric acid, and particular ethanol gives different type of product with the action of concentrated sulfuric acid. Okay, student, this much today, and you go through the reactions. You try to write the reactants. You first to write the reactant sign while you are reading. After complete the reading, try to write the product. If you are capable to write the product, then we can capable or what I mean, we understand what I study, and try to apply how the conversion are taking place, how the OH groups convert to different type of compound, different class of organic compound. Okay, students, thank you all of you.